Hello, this ELPRO training video is to show how to set up the 915U-2 radio system with 3 remote radios that have 4 to 20 milliamp and discrete I/O wired into them. At the master radio, we're going to assume this radio is talking via Modbus TCP to a PLC or what could be a DCS or a computer running a SCADA software program or any of those types of devices. This is what the layout of the network is going to look like. The only slight change from this diagram would be that we are going to have 3 remote sites, all sending their signals back to this master radio. The master radio will be set up for Modbus server mode, such that the master PLC here can act as the Modbus client. The 2 devices will be connected via a standard Ethernet cable. At remote site number 1, we're going to assume we've got 4 to 20 milliamp inputs and 2 4 to 20 milliamp outputs going to devices such as this variable speed pump, and then some analog inputs such as this temperature transmitter, which could be a level transmitter, pressure transmitter, any type of 4 to 20 milliamp device. Then we're going to assume we have some digital inputs as well as some digital outputs. The digital inputs in this example could be a level, temperature, or pressure switch, or any type of switch. The digital outputs in this case is just a pump with an on-off control. Okay, so this one shows you the general layout, and these radios will be linked by radio communication back to this master. And of course, these are mesh type radios. So if one radio does not have a direct path back to the master, it will communicate its data to one of these other remote sites, which does have a clear path back to the master device. No setup is required for the meshing configuration. The radio system will automatically determine this as needed. Now here is the register numbering that we are going to use for our configuration. In the left-hand columns, we have I/O coming from the remote sites, which is going back to the master radio. And then in the central column, we have I/O from the master radio that is going out to the 3 remote sites. At remote sites 1, 2, and 3, we will take analog inputs 1, 2, 3, and 4, and we will transfer them to these registers on board the master radio. So remote site number 1 will occupy register locations 40,010, 11, 12, and 13. Remote site number 2 will occupy registers 40,014, 15, 16, and 17, etc. So these are all consecutive registers. So from the master PLC, we could just have a single read command where we read registers 40,010 through 40,021 to gather all of these analog inputs at the remote sites. Then we're going to assume that this master radio or master PLC is doing some control functions, and that we have some I/O at the remote sites that we need to control. So we're going to take generic registers 30,000, 501, and 502, and then of course 503, 504, etc. here. And we're going to send them to remote site number 1, analog outputs 1 and 2. Remote site number 2, same analog outputs, and repeat the same at remote site number 3. All of the I/O is designed so that nothing overlaps. So you see all this I/O on board the master radio. Everything is a different I/O point. So there is no overlap of I/O at the master radio. At the remote sites, the I/O numbers are the same because these are addressed differently via IP addresses. So these register numbers will be the same from site to site. Now, one important consideration to be aware of is that the digital channels are used as, let's take that back one. The digital channels are used as both inputs or outputs. They can only function as one at a time. So in this case, we're using DI1 and 2 as as inputs. And then at that same site, D3 and D4 will be used as outputs. So in this case, we're just making careful that we don't overlap and use a digital point as both an input and an output at the same time. Okay. Now the IP address of the master radio, we're going to set it to 192.168.0.99 so that your PLC just needs to be set up to read information from this single IP address. Now for the analog I/O, 8,192 equals 0 milliamps, 49,152 equals 20 milliamps. So when we have a analog input here that's going to this master, this register on this master radio, this is what the scaling of the 4 to 20 milliamp signals will be. And it's the same if we write a value between 8192 and 49,000 to these analog outputs, they will produce the appropriate milliamp output. Digital I/O, obviously a 0 is off, a 1 is on, very simple for the digital values. Okay, now we're going to jump to the meshing configuration software, and I'm going to show you how to create this type of setup. The first thing we need to do is we need to create a new project. Okay, it's going to ask us what country we are located in. We have to tell it what country first, and then hit OK. Now we just have to type in a file name for this project, and I'll just change that to example configuration. Okay, we hit save, and presto, we have created our new project. Now the first thing is we need to add the 4 radios to the project. So we click Add New Unit, select the unit type, and hit OK. We repeat this process 3 more times. Once we have our 4 radios on the screen here, I'm going to change the name of these radios so that they are easier to understand. I'm going to call this one the master radio. I will refer to this one as remote number 1. And each time I click on the next radio, you can see that it updates the name in the project tree on the left. Okay, now I have successfully renamed my 3 radios. Now what I'm going to do is I'm going to set up the mappings going from remote number 1 back to the master radio. So what we do is we click on the arrow next to remote number 1 to expand the tree. Then we click on mappings. We click add to create a new mapping. I am going to transfer all of the analog and discrete I/O in a single mapping by using a gather scatter right mapping. I'm going to select the destination is the master radio, and specifically its radio port as opposed to its Ethernet port. So we want to select the master radio's radio port here. Then we need to start with the I/O on board the remote 1 radio. And in this case, we want to send digital inputs 1 and 2. So I'll go ahead and hit apply. And I have to set my I/O count to 6 data points. So I'm going to send the 2 discretes and the 4 analog values. Okay, now that I've sent analog 1, I'm going to go ahead and select analog input number 2. And in case it didn't pop up automatically, you would just select this tab up top here. Okay, now I need to go ahead and select my analog inputs. So I select analog inputs, click on analog input 1, hit apply. Then we repeat the same. Analog inputs, analog input 2, and hit apply. Okay, repeating the same for analog input 3. Lastly, analog input 4. Okay, now for my remote address, I can go ahead and click here. And now I have all of the remote locations on board the master radio. Now I'm going to double check to see what address I wanted to send everything to by going back to our spreadsheet. So we wanted to send analog inputs 1 through 4 to registers 40,010 through 40,013. Therefore, let's see here. I'll click on this one here. We'll select analog outputs, and I'll select register 40,010. Okay, now as long as there is no name next to a register number, it is a generic register that can be used for any purpose. Okay, so then we have register 40,010. The next one, analog outputs, there we go, 40,011. Hit apply. Okay, analog outputs, 40,012, and hit apply. Lastly, analog outputs, register 40,013, and hit apply. Okay. For the digital signals, let's go back to our spreadsheet. We were going to send them to registers 10 and 11 on the master radio. Okay, so in this case, we hit digital outputs, and we select register 10, and do the same for DI2, select register 11. Okay, and now we've pretty much finished setting up this mapping. I'm going to do one special trick here. I'm going to click acknowledge, and I'm going to select digital output 8 to act as our fail register. In this example here, digital output 8, and specifically the LED right next to it, will turn on if this wireless mapping fails to get through to the master radio. If digital output 8 is off and the LED right next to it is extinguished, then this mapping was successful and all of these values were written appropriately. Okay, now I'm going to do some other settings here. We're going to get rid of this delay so that the radio transmits a little bit faster. And we're going to leave the update time at 10 minutes. Okay. Then we go ahead and hit apply. And we have now finished sending all of the IO from remote site number 1 to the master radio. The next step is to repeat with remote radio number 2. So I go ahead and hit click on mappings for remote number 2, click on add, then we click on our gather scatter mapping, and we select our destination radio, which is the master radio, and specifically its radio port as opposed to the Ethernet port. Then we go ahead and set up the IO in the same fashion that we did before. And let's see, in this case, we wanted to send DI1 and 2 and analog inputs 1, 2, 3, and 4. So let's go ahead and select DI1, hit apply, but we have to set our IO count to a value of 6. Okay. Then we'll go ahead and select DI2 and hit apply. Now we'll go ahead and get our analog values. So we'll click on analog inputs, analog input 1, and hit apply. We'll repeat the same for analog input 2 and apply. And again for analog input 3, and we hit apply. Then the same analog input 4, and now we have selected all of our inputs that we wish to transfer. For the destination radio, which is our master radio, we now have to select where we would like this to go to. I'm just going to double check on our master radio, our register scheme. The digitals need to go to registers 12 and 13. So we go over here and we select register 12. Now you can see that registers 10 and 11 already have values mapped to them, so thus their digital signal is grayed out. Okay, we hit apply, and we want to send this one to register 13. Okay, and for the analog values, let's head back to our spreadsheet. We want them to go to register, starting at register 40,014. Okay, so we head over here and we select analog outputs, and we want register 40,014. Okay, now the next ones we know are all going to be consecutive, so we click analog outputs, and we're looking for register 40,015. Okay, then we do the same, click analog outputs, go to register 40,060, and hit apply. Okay, final register here, going to location 40,017. And apply. Okay, and I'm going to do the same thing here. I'm going to set up digital output 8 to act as our fail register. Okay, then I'm going to head over to the advanced tab, get rid of that 1 second delay to speed the response time up. Okay, and now we hit apply, and we have completed the mappings from remote site 2 back to the master radio. The next step is to repeat that process for remote site number 3. So I just click on the tree to expand it, click on mappings, then we click on add. Now we again use a gather, scatter, write mapping, and we select the destination is the master and its radio port specifically, not the master's Ethernet port. Okay. Then we set our I/O count to a value of 6. Okay, then we have to select our local inputs. It was digital inputs 1 and 2 that we wish to select. So we'll start by selecting these two guys here. Okay, then we want to select analog inputs 1, 2, 3, and 4. So we click on analog inputs, AI1, and hit apply. Then we do the same, AI2, and apply. Analog inputs, AI3, and apply. Analog inputs, AI4, and apply. Okay, now that we have completed that, we need to tell it where on the master radio these values are going to go to. I can go back to my spreadsheet here and see that the digital inputs from remote site number 3, remote radio number 3, are going to go into registers 14 and 15. 14 and 15 down here. Okay, so I head up here and I click on digital outputs. Well, that comes up as the default there. And it was to registers 14 and 15. 50, there we go. Okay. And for the analog outputs, let's head back to our spreadsheet. We wanted them to go start at register 40,018. Okay, so we head over here, we click on analog outputs, and we scroll down a little bit, and we start at 40,018. The next, analog outputs, 40,019. The next, click on analog outputs, 40,020. And lastly, click on the final data point, 40,021. Okay. And then we're going to do the same on this one here so that we can, if we're at remote site number 3 and we're able to observe the terminal block, we can look at digital output 8 to see whether this mapping was successful. Okay, off is good, on means the mapping failed. Okay, and we'll do the same thing. We'll set that delay to 0, and presto, our mapping is complete. Now keep in mind, if any of these discrete values change state, or any of the 4 to 20 milliamps change by more than half a milliamp, this mapping will be transmitted immediately, and all of these values will be updated at once. Otherwise, if none of them change and any of the analog's values change by less than half a milliamp, it will be transmitted every 10 minutes. Okay, then we go ahead and hit apply, and presto, we're done. We have mapped all the I/O from the 3 remote sites back to the master radio. Now, there were some extra functions we wanted to do. We wanted to write some values from the master radio out to these remote sites, the analog outputs and the digital outputs. So we need to create some mappings on the master radio. Where we would do so, we click on the master radio, expand the tree, and then click on mappings. We would click on add, and then to send all the analog and discretes as a single mapping, we'll set up a gather, scatter, write mapping. The first one we're going to do is to remote site number 1. Okay, and we are going to send 4 data points, 2 analog and 2 discrete. Okay, so first of all, we have to tell it where do we wish to send the values from. Well, we're going to click on general analog inputs, and these are inputs that can be used for any purpose. And we're going to start off with register 30,501, hit apply, and then it was register 30,502. So we click on general analog inputs and 30,502. Then for the discrete values, let's head back to our spreadsheet to see which registers we wanted to send, 10,501 and 10,502. So we click on this point here, then we click on general digital inputs, general purpose, so they can be used for anything, and we'll click on 10,501, hit apply. Repeat the same thing, general digital inputs, 10,502, and apply. Okay. Then for the remote addresses, we wanted to send this to analog output 1 on this remote radio. So we just click on analog outputs and select analog output 1 and apply. Then we do the same for analog output 2, and we select analog output 2, then hit apply. For the digital values, these were going to digital outputs 3 and digital outputs 4. So here we just select digital output 3 and the same digital output 4. Okay. Then lastly, we're going to acknowledge the message. So in this case, we're also going to use digital output 8 to indicate the status of this transmission going from the master to remote site number 1. So if all goes well, digital output 8 will be off. Okay. Then we'll click over here to the advanced tab, and we'll set the delay to a value of 0 and hit apply. Now we've got the mappings going out to remote site number 1. Now we're going to set up the mappings going to remote site number 2. Okay, so we'll hit gather scatter. We'll select the destination radio, and we are going to send 4 I/O points across. Now heading back to our spreadsheet, we want to send registers 30,503 and 504 two analog outputs 1 and 2 on the remote site. So that's 30,503 and 504. Okay, so we head over here, we select general analog inputs, and we select 30,503. Then we repeat the process again, general analog outputs, 30,504 for analog output 2. Here it was the same, it was register 10,503 and 10,504 that we wish to send to the remote site number 2. Okay. And at the remote site number 2, it's just analog output 1 and 2. So we head over here, click analog output 1 and apply, and then repeat the same for analog output number 2 and then apply. For the digitals, we wanted to send them to digital outputs 3 and 4. So we just select digital output 3, hit apply, and then digital output 4 and hit apply. Okay, now our mappings are complete. We're going to do the same, except for remote site number 2, we're going to use digital output 7 to indicate whether radio communications are successful and whether this mapping specifically made it to remote site number 2. Again, this provides you a visual indication as to whether it was successful, and if you like, you could wire something to this digital output here. Okay, we're going to get rid of our 1 second delay and hit apply. And now we have this data going to remote site number 2. Third step is just to repeat that for remote site number 3. So we click our gather scatter, we select remote 3-radio, and we select 4 data points that we're going to send. Now let's head back to our spreadsheet. We want to send register 30,505 and 506 to AL1 and 2 at remote site 3. So 30,505. Okay. So then we head to general analog inputs, click 30,505 and apply. We click again general analog inputs, 30,506 and apply. Then for the digitals, it is register 10,505 that we wish to send over, and 10,506. Okay, we'll just double check those numbers with our spreadsheet. Yep, it's 10,505 and 10,506. Okay. At remote site number 3, we want that first register to go out of analog output 1. Okay, so we click analog outputs, AL1, and apply. The next one goes to analog output number 2. Then we hit apply. Okay, then we have the digital outputs. And we wanted them to go to digital outputs 3 and 4. Okay, so over here, we just select digital output 3, and then we select digital output number 4. Okay. Again, I'm going to set up a fail register, so I have to click acknowledge. Then I tell it which register I would like this indication on. I'm going to use digital output number 6 to indicate the success of a transmission going out to remote site number 3. So DO6 is remote site number 3, DO7 was remote site number 2, and DO8 was remote site number 1. Now at this master radio, I could have a PLC and I could have it reading the status of these digital outputs if I wanted the PLC to know whether communications were successful. Okay, I'm going to head over here, get rid of that 1 second delay, and now we are complete. So that is it for mapping the I/O from one radio to the other. The last is we have to set up Modbus. Okay? So all we need to do is just click on Modbus on the master radio and make sure we have Modbus TCP server enabled. And then we're all set. If we have a look up top at our IP address, this shows us the IP address of the master radio. So this is what you would direct your Modbus server to read from. So 192.168.0.99. Now you'll see the other radios also have their Ethernet ports set to the same value, and that is fine because these radios, the Ethernet ports are not bridged together. It's only the radio ports which have different IP addresses, and the radio ports are bridged together. And the 915 acts as a router, routing data between these two only where required. Okay, so that is pretty much the entire setup. The only final step would be to take your 4 radios, plug into them directly, and click on Program Unit. So right now I would have an Ethernet cable plugged between my computer and the radio. And right now this IP address has to be the IP address that is inside the radio right now. So if the radio has never been programmed before and it's brand new right out of the box, the IP address in the radio will be the setup IP address that is printed on the side label. That will be a IP address in the range of 192.168.0, and it will be between 100 and 199. So we just enter that IP address, whatever's printed on the side label, into this box right here, and then we hit OK, and the radio will go ahead and program the unit. Now you have to make sure that your laptop's Ethernet port is set to something on the same subnet here. So what I do is I set my Ethernet port of my computer to 192.168.0.5 or 6 or something of that sort, but it cannot be the same as the radio. So if I set my radio, my computer anywhere from .1 to .98, then it will not overlap with any of the radios even before or after programming. Now, after you have programmed this radio, it will now have this new IP address. So if you have programmed this radio before, then what you do is you just enter this IP address into this box. So just in summary, this IP address must be what is in the radio right now. Once we have programmed all the radios, you just need to power up the radios, apply your 4 to 20 milliamp and discrete signals, and then presto, you can then read them from the master radio. Now keep in mind, the radios were set by default just to transmit every 10 minutes, unless the 4 to 20 milliamp signal or discrete signal changes. So you may have to power up these radios and wait 10 minutes if you don't change any of the I/O before the registers on this master radio are fully populated. So just be patient, wait the 10 minutes, or you could take a jumper wire and short it across DI1 on the remote radio, and then DI2, and then DI3. And then we should then see the radios transmit. And at that time, we will see the LEDs next to DOs 6, 7, and 8 turn off as the radio communications are successful between the remote sites there. So just be patient or get a jumper wire and short the inputs to force a transmission to occur. Now, if you have any questions, I do have this entire configuration saved that I could email you. I also have this spreadsheet here that I could email you as well, and it shows just a general layout or typical layout of a couple of remote sites, and it shows you what registers you need to set the PLC to read. Thank you, and I hope this has been helpful. And if you do have any questions, we are available by phone and email for support.